Greeting students, welcome back to our YouTube channel Nagin Best Digital Learning. In this video of the chapter Electricity of class 10th, we will discuss about the very first topic, electric potential and electric potential difference. See, before understanding the concept of electric potential, we have to understand or we shall think about or talk about the following analogies of the nature. The very first analogy is, if a ball is placed on an inclined plane, it rolls down and we say that it has moved from a position A of higher gravitational potential energy to a B of lower gravitational potential energy. It means we can simply say that it has moved from a greater height at point A to a lesser height at point B. Here is the diagram of the above analogy, that in the very first diagram, the point A is raised from the ground level by a height h. The point A is slightly greater than point B, while point B has zero gravitational potential energy. We need not to do any work by inclining down the ball A to B. Similarly, the second analogy is, here in the second diagram, we have two tanks A and B containing a liquid which are joined together through a pipe with a tap T. As you can see in the diagram, the liquid flows from tank A to tank B when the tap T is opened. From this level to this level, liquid flows. Now the question arises, why this is happening? This is due to the reason that pressure of a liquid in tank A is more than in tank B, because level of liquid in A is higher than that in B. Moreover, so liquid keeps on flowing as there is a difference in levels. The main and tagline of this is, why the liquid is flowing from tank A to tank B, and the answer is difference in the pressure. And liquid is flowing from a higher pressure to lower pressure. In the previous example also, the ball was sliding down from a point of greater height to a point at lower height. For the same, let us consider if we join two hot bodies. Suppose we have two hot bodies and let us join these two hot bodies by means of any metallic conductor. Then what does happen? Heat flows from the body at a higher temperature to a body at lower temperature. The flow of heat also governed by the principle that heat flows from higher potential to lower temperature to lower temperature, and the flow of continuation of heat will remains till the temperature of the two bodies becomes equal. As in electricity, the potential is like a height, level, or temperature. We can correlate the concept of potential with the concept of this height, level, and temperature as discussed above in the three analogies. Moreover, we know that when a body is raised to a height or a level of a liquid in a vessel is raised, or the temperature of a body is raised, it means if we want to take any ball from zero height to some height, if we want to raise the pressure of any quantity, if we want to raise the temperature of any body, in doing so, work has to be done. Means we have to do work in charging a body. The same amount of work done is stored in a body is known as electric potential energy. In order to charge a body or to raise its potential, we have to do some extra amount of work. That work done is stored in the body in the form of electric potential energy. This is the concept that we can better understand with these type of analogies. Now this is electric potential energy. Now the question arises how we can define electric potential. Electric potential energy per unit charge is called electric potential. So basically we can say that electric potential energy is a kind of work done. So electric potential's formula will becomes electric potential energy, that is equivalent to work done divided by energy. Work done divided by charge on by which the electric potential is to be raised. Now apply the same concept of electric potential difference to the analogies in case first, second and third. A body cannot move on level ground by itself when there is no height difference. The very first question arises that if a ball is lying on a ground plane, the body cannot move itself. It is because there is no height difference. A liquid on its own does not flow without level difference. If we have two containers and in both of the container the level of the liquid is same, then the liquid will not flow from any part. It will remains same as there is no height difference or no pressure difference. Heat does not flow when two bodies, suppose one body is having a heat of 100 joule, another body is also having a heat of 100 joule. If we will connect these two bodies by means of any resource or say a metallic conductor, the heat will not flow neither from first body to second nor from second body to first. This is because at both the ends the temperature is same or the temperature is difference is zero. Similarly, by understanding these concepts, we can say that in case of electrical or electricity, for the ordered flow of charge, if we want that the charges must flow in a particular or ordered form, there should be some difference of electric pressure. That electric pressure is known as electric potential difference. This difference of electric potential is provided by an electric cell. Then the question arises, and such type of questions can be asked either in 1 mark or 2 mark, that name the device which is used to maintain electric potential difference between the two terminals. Here the device can be a battery, a cell, or a generator. Means if we want that the electric charges must flow in a ordered form, for that particular reason we need an electric cell, electric battery, or a generator. Now we know that difference in gravitational potential energy is measured by height. Difference in pressure in tanks A and B, as discussed earlier by the help of two diagram, is measured by the difference in level. Difference in temperatures between two hot bodies can be measured with the help of a thermometer. Similarly, the potential difference between 2 points A and B on a conductor is measured by the amount of work done to move a unit charge from A to B. As like temperature difference, pressure difference, and height difference, potential difference between 2 points on a conductor is measured by the amount of work done to move a unit charge from a point A to point B. And for a practical reason, if we want to measure the with the help of a particular instrument, that instrument is known as voltmeter, that must be connected between points A and B. See, how should we define electric potential difference? Electric potential difference between 2 points on a conductor through which a current is flowing. It means consider 2 points A and B, and from point A to B, suppose current is flowing, then the amount of work done in moving a unit charge from A to B. Means we have to think about the amount of work done in moving a charge from point A to point B. If suppose if we are doing W, capital W amount of work done in moving a charge of capital Q from point A to point B, then how potential, work done, and charge can be interrelated with each other. Suppose this is W and W is equals to Q into V, or moreover we can say that V is equals to W divided by Q. This is the formula for electric potential. V is equals to W divided by Q. Now, as we know that the device or the instrument which is used to measure electric potential difference is voltmeter, and what should be the unit of electric potential? The unit of electric potential is known as volt, and it is on the behalf of an Italian physicist named Alessandro Volta, who discovered the concept of potential difference. In his honor, the unit is decided as Alessandro Volta. Potential difference, written in short as PD. In the coming PDF where PD is written, we will consider is potential difference. Between 2 points, it is said to be 1 volt. The potential difference between 2 points can be set to 1 volt if 1 joule of work is done to move 1 coulomb of charge from one point to other. let me speak again. Whenever we will consider point A and point B, then in between the 2 points, the potential difference can be set to 1 volt. If 1 joule of work is done to move 1 coulomb of charge from one point to other. From this very basic formula, we can write 1 volt is equals to 1 joule divided by 1 coulomb. So 1 joule is equal to 1 volt is equal to 1 joule coulomb inverse. Now let's come to the next topic, and the name of the topic is electric circuit and its components. We have discussed and we are aware about electric lamps, heaters, air conditioners, motors, and various other devices which work on electricity. These are called loads. In terms of physics, we can say that load means any electric energy consuming device. Any device which is consuming electric energy can be considered as load. In order that electricity flows through a load, it has to be connected to a source of electric power. If we want to be considered that electricity is flowing through any load, it can be happen only if the source is connected to any electric powers. For example, a battery or a generator through wires. If we have a fan or a bulb or a heater, connecting wires we have, till the wires will be connected to a battery, to a cell or to a generator, only then electric current can pass through that particular device. Further, we use switches to switch on and switch off the power and some other components. We can say elements also. From here we can say that a source of electric power, which can be a battery or an AC source, loads and switches and other elements connected together by wires form electric circuit. Further, we can conclude that a particular arrangement of all the electrical components together, connected together by means of wires, constitutes electric current such that an electric current flows overall through the circuit. A drawing showing the way the electrical devices are connected in a circuit is called the circuit diagram or a schematic diagram. First of all, we have to take a layout while drawing all the components together, that this component must be arranged here, like this component must be arranged here, that a particular pattern that should be there on the page, that drawing is known as the schematic diagram or electric circuit. In these diagrams, while representing such type of diagrams, there are certain symbols that must be used to show that the various devices, and that particular symbols are given here. These are the particular symbols. Now let us understand these symbols one by one. If we get a straight line, this straight line means it will be used for connecting wire of a conductor. And suppose if there are, this is the second one, if there are two wires and this type of diagram we have, it means the diagram is, or the symbol is showing that the two wires are connected. Joint is shown by such type of diagram. In the third one, one wire is on the other wire, but here the one wire which is from the upper side is not connected or joined on the lower wire. It is just on the upside of the wire. It is not connected, without connection. This is a symbol which will be used very regularly in the chapter known as resistor. A resistor is a physical device while resistance is its property. Come to the next symbol. Here is a variable resistance. Variable resistance general symbol is like this. If we have a symbol of resistor and we will mark an arrow on it, it will becomes a variable resistance. We will discuss further about this topic in our coming videos. Now, one more topic is rheostat, unknown variable resistor. A arrowhead or a tapping on the resistance should be there. It will be a rheostat. A symbol like this, resistance box. If we have two brackets and with the two brackets there are two straight lines like this, and in the middle one it is empty, then it means this is a plug key or switch which is open. It is a type of plug key or switch which is open, and for that circuit in which this type of symbol is connected, we will say that circuit as open circuit. And whenever open circuit will be there, no net flow of charge or current will be there from the circuit. And in the next symbol, the two brackets with a dot in between them, it means the dotted line shows that the circuit is complete. Now for this time the current will flow through the circuit. This is the tapping key. This is the symbol used for electric bulb. This is for electric bell. These are the two circles known as shows the terminals or connections. This is electric cell, and if we connect more than one cells, it will becomes a battery. A rounded shaped written capital G in between it is galvanometer. This is the symbol of voltmeter which is used to measure voltage. This is the symbol of ammeter, which is known as a device which is used to measure the electric current. Now, further, a few things about the element shows about their worth meaning. Let us understand a few terms related to the symbols we have discussed above. A connecting wire is basically made of a copper, which may be thick wire or several fine wires placed together. It is covered with cotton or plastic insulation. The resistance of connecting wire is negligible as taken 0. Many of the time you have seen at your home or in your practical lab that there is a wire which is basically covered with a thread or with a plastic insulation. The point 2 comes about resistors, rheostats and resistance boxes. These type of materials also consists of wire which are generally made up of alloys such as manganese and constantan. Whereas a resistor provides a constant resistance in the electric circuit. A rheostat and a resistance box are used to change resistance in an electric circuit. A resistance may be considered as a fixed value of resistance, while the rheostat and variable resistance, these provide a flexible or variable value of electrical resistance to the circuit. Now, the point third comes about a battery. We can say that a battery is a combination of two or more cells. One thin long line represents the positive terminal of cell, whereas the short thick line represents the negative terminal of the cell. The bigger one in the symbol of cell, the bigger line represents the positive potential, and the smaller one will be considered as the negative potential. This is because in the in tradition we will consider that positive charge is always as the highest potential charge. We will consider positive charge as the higher potential. The line in the battery or a cell, bigger line shows that this is positive charge, this is the higher potential, and the lower one it shows that it is at lower potential, it is negatively charged. We will consider negatively charged part as a lower potential. Now we have seen a galvanometer. It is a device which is used for detecting flow of electric current. It has no positive or no negative terminals marked on it. Further, there was a device known as ammeter, a very short form of ampere meter. And as the name indicates, ampere meter, this device is going to measure electric current. It has positive and negative marks on its terminals, and according to that, the positive should be connected to the positive of the battery and negative should be connected to the negative of the battery. And after doing so, we can say that for the same reason, ammeter is always connected in the series with the circuit. Another device is also a device named voltmeter, which is used to measure potential difference between the 2 points in any electric circuit. As like ammeter, a voltmeter also have two terminals. One is positive, another is negative. A voltmeter is always connected in parallel with the circuit, with its positive terminal to the point at higher potential and negative terminal to the lower potential. Now, one term is there known as a closed electric circuit. A closed electric circuit is one in which the key is closed and the current flowing continuously to the electric circuit. On the other hand, in point number 8, it is discussed about an open circuit. An open electric circuit is one in which the key is open and there is no flow of current. Whenever open circuit will be there, no current will be flowing through the circuit. Here, for the understanding, a schematic diagram is given of an electric circuit which consists of a cell, a bulb, a plug key, an ammeter, The electric current flows in the circuit from the positive terminal of the cell to the negative terminal. Now let us understand it. Here one battery is shown. See, this is the cell, this is electric bulb, this is voltmeter, this is key, this is ammeter. If all the components will be arranged in such a way that it will form a schematic diagram of an electric circuit.